Your data can be distributed in different ways. Maybe your data points are skewed to the left, skewed to the right, or they're uniformly distributed, like this. But in real life, many things look more like this. This is a normal distribution. We spend a lot of time studying normal distribution because it's very common in both natural world and our human society. Things like height, body weight, and household income are just some of the things that are normally distributed. In this video, you will learn how to interpret a normal distribution. One characteristic of a normal distribution is that the mean is exactly in the middle. That means there are just as many data points to the left of the mean as there are to the right, which, by the way, is also the definition of median. Median is literally the number in the middle. So you can also say that in a normal distribution, the mean is the same as the median. Another characteristic is that a normal distribution is symmetric. Even when the mean is the same as the median, if it looks like this or this, you can't call it a normal distribution. Let's say I'm studying the average weight of dogs. An adult dog's weight can vary quite a lot depending on its breed. A fully grown Saint Bernard can weigh 80 kilograms, whereas a typical Yorkshire Terrier weighs less than a kilo, and most other dog breeds sit somewhere in the middle. I ran a survey of all the dogs in my neighborhood. I asked the dog owners to weigh their dog and send me the measurement. Next, I divide up the measurements into a few groups. Let's start with the intervals of 10 kilo. So I check the survey result. If I see a dog that weighs between 0 and 10 kilo, in other words, greater than 0 and less than or equal to 10 kilo, I record this in the first category. I add one block in this category. If I see a dog that is greater than 10 and less than or equal to 20 kilo, then I will add it to the second category. There should be a few more dogs in this category than the first. If I repeat the process, I should get something that looks like this. As you can see, most of the dogs are somewhere in the middle. These are the Labradors and Collies of the world. And if you start to connect these bars at the top, you get this a little awkward pointy shape. This is not quite a bell curve yet. To call this a curve is a little bit ambitious at this stage. What I'll do is I'll subdivide each category by half. Instead of using intervals of 10, I'm going to use 5 kilograms this time. So the first category is going to be greater than 0 and less than or equal to 5 kilograms. And the second one is going to be greater than 5 and less than or equal to 10 kilo. You see that the lines are a little bit smoother this time. As you keep subdividing these categories into even smaller bits, the straight lines will become smoother and smoother until eventually they form one smooth bell-shaped curve. This is how you get a normal distribution. This kind of curve is called a density curve, whereas the bar chart I was using earlier is called histogram. There are two different ways to visualize the same data points. One way of analyzing a normal distribution is by looking at its standard deviation. I will do another video and explain how to calculate standard deviation, but in this video I would like to give you an intuition of how to make sense of it. Standard deviation shows you how spread out the numbers are. In other words, it is a measure of how far or close the numbers deviate from the midpoint, which is the mean in a normal distribution. If the standard deviation is low, that means all the numbers are clustered together. If the standard deviation is high, that means the numbers are distributed further and wider apart from the mean. Now that we are familiar with the idea of standard deviation, we can talk about the empirical rule of normal distribution, or 68, 95, and 99.7 rule. The rule says 68% of the data points should fall within one standard deviation of the mean. Similarly, 95 and 99.7% of the data points should fall within 2 and 3 standard deviations from the mean, respectively. Let's say the average or the mean weight of a dog is 40 kilo, and the standard deviation is 10. To find out what one standard deviation covers, you start from the middle. You start from the mean and you move by 10 kilo both to the left and to the right. This covers the range between 30 and 50 kilograms. And the empirical rule tells you that 68% of all the dogs we're studying weigh between 30 and 50 kilo. Now, if you go 2 standard deviations away from the mean, you can say that 95% of the dogs weigh between 20 and 60 kilograms. Let's expand the range to 3 standard deviations away from the mean. This is going to cover 99.7% of all the dogs we're studying. Okay, thank you for watching. I hope this was useful. If you like this video, please subscribe to this channel up here. If you'd like to watch more videos like this one, you can keep watching the series down here. Thank you for watching. See you in the next video.